Assalamualaikum and good day, dear student. So now let's discuss together example midpoint method. Okay, so by referring to the same example as in Huynh methods, so now we're focusing on midpoint method. So you asked to estimate the initial value problem, okay, for the case of first order dy dx equal to exponent negative 4x minus 2x plus y, where x is defined in between 0 and 2. Okay, we're only interested for this range only. And then given here is the initial condition. Alright, so this is our initial condition. So as I told you, this is mean that x not equal to 0. Okay, your y not equal to 1.0. Okay, so now let's focusing on RK2 by using midpoint method. So we will look at how we obtain the solution, means that the function at several value of x by using midpoint methods with the set size h equal to 0.5. Okay, so again, in order to help you, okay, so I got you, so I put the formula here, so you may refer to this formula, okay, midpoint formula. So later on when we do the calculation, okay, you may look at this formula here. If let's say that you forgot about the formula, so you may refer here. Okay, so let's start our calculation. Okay, so the first one, this is your function, okay, your first order. So I may write this in this form: f xy is equal to exponent negative 4x minus 2x plus y. Alright, and then we are given the step size delta x or h is equal to 0.5. So now if we draw our timeline, so this timeline to give you the idea on how many solution that you must to compute. Okay, so with the starting value x naught equal to 0, and then we have our x1. So again, as I told you, x1 is the increment from x naught plus with your step size. Okay, so x1 is equal to 0.5, and the next one x2 equal to 1.0, and then you have your x3 equal to 1.5, and then the last one x4 equal to 2.0. So we only need to calculate up to 2 because based on the range of your x here. Okay, then at this point y0 is equal to your y naught, which is 1.0. Okay, so this is our task. We must to compute the solution for y1, y2, y3, and the last one y4. So we want to compute all this using midpoint method. Okay, midpoint methods. Alright, okay, so now let's start our calculation. So we have I write again here our fxy is exponent negative 4x minus 2x plus y. Okay, so we begin with I equal to 0. Alright, so when we calculate later, y1 equal to y naught plus k2 times with your step size. Okay, so where k1 is a calculation of your slope at the point x naught, y naught. So x naught is 0, y naught is 1. So substitute into our differential equation. Okay, exponent negative 0 minus 2 times 0, and then plus with 1. So you may get your k1 equal to 2. And then for second slope, k2, so we want to find our slope at the point x0 plus half of your step size, and then y0 plus half time with the k1 time with step size. Alright, so if I simplify here by substituting all the value, so I have this 0 plus half time with 0.5, and then here is y0 is 1 plus half time with k1 is 2 time with step size is 0.5. So if we simplify here, we should get 0.25 for x, and then 1.5 here. Plug in into your equation, exponent negative 2, is exponent negative 4 times with your x 0.25, and then minus with 2 times with your x 0.25, and then plus with y 1.5. So you may get your K2 equal to 1.3679. Okay, if you set your calculator into 4 decimal places. Alright, so from here, okay, I may get the first function approximation y1 equal to y0 is 1 plus with k2 1.3679, and then time with my step size 0.5. Okay, so here I may get 1.6839. So this is my first one, y1. Next we continue, I equal to 1. Okay, so now we want to calculate y2 equal to y1 plus k2 times with step size, where first we calculate our first slope k1 equal to f at the point x1 y1. Okay, so we substitute all the value 0.5 and y1 from the previous calculation 1.6839. Okay, substitute into your function or equation, 2 times with your x and then plus with y 1.6839. So here we may get k1 equal to 0.8192. Okay, so next here I calculate my k2. So I continue here for k2. So K2 is a calculation at the midpoint. So here is x1 plus half of your step size, and then here is y1 plus half of your k1 times with your step size. Okay, so if we substitute the value and we simplify, we should get 0.75, and then for this part is a 1.8887. Okay, so substitute into the equation, exponent negative 4 times with x minus 2 times with x, and then plus with y 1.8887. Okay, so from here you may get your K2 is equal to 0.4385. Okay, so because of that, we can update the function value here. Okay, using midpoint, so y2 is equal to y1. So previously y1 is a 1.6839, and then we plus with our k2 0.4385, multiply with the step size 0.5. Alright, so here you should get your y2 equal to 1.9031. Okay, this is for y2. Okay, so next we continue. I equal to 2. So this time we want to calculate our y3 equal to y2 plus k2 times with the step size, where the first slope k1 is equal to f at the point. x2, y2. Okay, so x2 is 1.0, y2 from the previous calculation 1.9031. Alright, so substitute into the equation, exponent negative 4 times with 1.0 minus 2 times with 1.0 and then plus with y, which is 1.9031. So here you may get your first slope k1 equal to negative 0.0786. Okay, then calculate your second slope k2. So k2 is at the point x2 plus half from our step size. Okay, and then y2 plus half time with our first slope time with our step size. So if we simplify, we should get here is a 1.25 and then here is a 1.8835. Okay, so substituting into the equation, exponent negative 4 times with x 1.25, then minus 2 times with x 1.25 and then plus with y 1.8835. So you may get your k2 equal to negative 0.6098. Alright, so student, from here, okay, by using midpoint formula, our third function, okay, y3, the computed solution for our y3 is equal to y2. So previously y2 is 1.9031 and then plus with your second slope, okay, and then you multiply with your step size 0.5. So here you may get the value 1.5982. Okay, so now we have the last part here, I equal to 3. So here we may calculate our y4 by using the previous y3 plus k2 times with h, where k1 is a calculation of our slope at the point x3 and also y3. So x3 is 1.5, y3 from the previous calculation 1.5982. Alright, so now we substitute into our equation, exponent negative 4 times with 1.5 minus 2 times with 1.5 and then plus with 1.5982. Alright, so if you calculate this, you may get your k1 equal to negative 1.3993. Alright, so then we calculate our k2. So k2 is a calculation of our slope at the point of x3 plus half of the step size and then y3 plus half of k1 times with step size. Okay, so if we simplify, so we get 1.75 for this point and then 1.2484, okay, for the other point here. So substitute into your equation, exponent negative 4 times with 1.75 and then minus 2 times with 1.75 and then plus with 1.2484. Okay, so from this calculation, you may get your second slope equal to negative 2.2507. Alright, so finally we obtain the value for y4 by using midpoint is equal to y3, so 1.5982 plus with our second slope negative 2.2507, okay, time with the step size 0.5. Alright, so if you calculate this, you may obtain your y4 equal to 0.4729. Okay, so therefore we we can make a conclusion. Okay, so this is our approximate value that we generate by using midpoint method. Okay, midpoint methods under RK2 range kata, second order range kata methods. So it means that the solution is therefore the approximate solution are, so y when x equal to 0 is simply equal to our y naught 1.0, and then y at the point 0.5 is approximated by y1, okay, which is 1.6839, and then y when x equal to 1.0 is approximated by y2 equal to 1.9031, and then y when x equal to 1.5 is approximated by y3 equal to 1.5982, and then the last one, y when x equal to 2.0 is approximated by y4, which is equal to 0.4729. So you may see here in this figure, okay, I plotted in the same graph the curve represent for exact solution, Euler, Heun, and also midpoint. So from here you may see that this is the curve for Z, okay, given by the black curve. The red curve here is the Euler, and then the blue curve here is the Heun methods. And then for the latest method, midpoint method, given by this cyan, okay, cyan color here. Alright, so you may see that the accuracy given by midpoint is much better than Heun and also Euler method, because midpoint is much closer to the Z compared to the other two method here. Okay, so in this problem we can say that midpoint improve the approximate solution done by the previous Heun methods. Okay, so student, I hope you gain something from our discussion in this example. You may have, I hope that you have the idea about midpoint, what is the improvement, okay, performed by the midpoint for this example, okay, in comparison with the previous Heun, and also if we use Euler to approximate our first order initial value problem for the respective example. Okay, so I stop here. Thank you for your attention. So we meet again in the next video to discuss about Western methods.